Okay, hello everyone, my name is Timothy Lee Grant and welcome to a video where we are going to be trying to do leak coding. Let's go! So, I am going to make myself a little bit smaller and we are going to select dynamic programming. So let's see what we can get. Alright, so what I'm going to do is just randomly choose the next medium that I see. So, I guess let's just try jump game. Sure, why not? Okay. Oh, I need to log in. Okay. There we go. So, let's read the problem. You are given an integer array nums. You are initially positioned at the array's first index, okay? Each element in the array represents your maximum jump length at that position. So I have this array here, okay? And each number, what does it actually represent? Each element in the array represents your maximum jump length at that position. So I think it means here I can jump 4 elements. Here I can jump 1 element, here I can jump 1 element, here I can jump 3. So I could be like here to here, or here to here, or here to here. I think that's what it's meaning. Return true if you can reach the last index, or false otherwise. Okay. So possibly that's not what it's meaning. You are initially positioned at the first index, okay? And each element in the array represents your maximum jump length. How would it be, unless we have negative numbers in there, how would it be possible, or if there's a 0, how would it be possible that we would not be able to reach the last index? And the reason that I'm asking that is because this says maximum jump length, which implies that I could do less. So like, I could do 1 to 1 to 1 to 1, and I'm there. So jump 1 step from 0 to 1, okay? And then from 3 to the last index. Or, as I just mentioned, like 1 to 1 to 1. So this one is false. Okay, so we do have zeros. So I could go 2, and then it lands here, and then, okay, I see. Then I could go like 3 and there, okay. I could go here and then there. I see how this is working. Okay, so I guess what I want to do, first thing with like dynamic programming, would be to try to make it into a recursive problem. So let me think about how I would do that. So let's see. Def recurse. Okay, I don't know what my arguments are going to be yet. I will then pass in, let's see, I want to pass in, my base case is going to be when I'm at the end, right? Okay, so if index, so I, is equal to, and I will calculate length is equal to length of nums, okay? If that's equal to length, then that means that we did hit a case that we ended up to the last element. So then at that point I can return true, okay? Okay, so this also means that I need an I in there. So from here I will do recurse and starting at the 0th index, and I need to capture this result. So result is equal to whatever here, and then return result. Or I could have just done return recursive 0. Doesn't matter. Otherwise, what's the other base case? If nums of I is equal to 0, return false. And the reason that I'm going to do this is because we're kind of stuck. If we get here, we're stuck. Okay? So those are my two base cases that I can think of. The other one is, and I will need to put it here so that we don't get out of bounds. So if I is greater than length, if it's greater than length, we're out of bounds, and we return false because that we didn't reach the end. Okay. So now what I want to do for the recursive step is going to say, I'm going to be at a specific element here, and I need to try everything starting from 2. I need to try taking 2 steps because I'm allowed to do that. I need to try taking 1 step, and then I terminate. Obviously I don't take 0 steps because that's not going to help me. But like for this one, I need to take 3 steps, and then I need to take 2 steps, and then I need to take 1 step. So let's, it's going to be some kind of for loop. So for num, what's a good, for jump in range nums of I. So this is going to give me, let's just say that I is equal to 1. So we're here. So it's going to give me 0, which I don't want to do. But we'll fix that later. And then it's going to give me 1, and then it's going to give me 2, and then it does not include 3. So we need to fix this. So we want to start, at 1. Okay. And then here, plus 1. Like that. Then we can result 1, temp result, okay? And then I'm going to do temp result is equal to false. And then if this ever returns a true, then I just want to keep popping back up and return true. So temp result, I'm going to say if temp result, so if it is ever true, I want to return true, okay? Otherwise, I just say, maybe I could have done that at the end, like this. Temp result is equal to recurse of I, my current index, plus the jump. Okay. Otherwise, we are going to come back up here and come here and try to do it again. We're going to keep doing that. And then I should return temp result, like this. Okay, something like that. Do we want to try submitting it? So this is result is not defined. Okay, so okay, whatever. Okay. So I think we got the correct. Let's just see if we can submit it. Now, we didn't do actual dynamic programming because we didn't save anything. So we're still doing all of those recursive calls. So now from here, I need to figure out how to actually optimize it. Okay, well, we got a wrong answer. So why? I don't know. Okay. It's probably paid for. Well, I have a free service that I can use. So why is this the case? Nums of 0. So we come in here. I is equal to the length. So length is going to be 1, and we are going to be at the 0th index. Oh, so it's going to be like that. And then, so this one is going to be greater than or equal to the length. We return false, and this one is, yeah, that one's fine. Okay. Let's see about this. Time exceeded. So yeah, we're. Can you please get out of there? I wish that they would actually tell me if it is a valid solution or not. They don't do that. They just give time exceeded. So I'm gonna come here and just see if Copilot tells me it's correct or not. Is this correct? Don't worry about optimization yet. Just let me know if my solution works. Okay. So let's see. Is functionally correct. Okay, good. So now what I need to do is I need to think about how can I take this and actually do the memoization. So with memoization, what I need to do is I need to create some kind of state, some kind of like grid. So I'm going to create a dynamic programming array is going to be equal to, what's the format? It's like a -1 for blank in range length. I think that's, so I'm creating an array and I'm filling it with -1s, and it's going to be of the same length that this nums array is going to be. So now what I'm going to do is I'm going to add another base case and say here if I've already found what do I want to say like -1, true or false. I guess those are the states that I can save. So -1 represents I don't know yet. True, we should just be popping back up, just popping up with true. But if I say false, I don't want to check that ever again. Because I already know that from that location, it's impossible to get to the destination, right? So if dp of I is not equal to -1, return dp of I. I think that's correct. And now what I need to do is here I need to say, I need to return this result. So I do a jump. So dp of I is equal to true. Otherwise, we have just found out that it is not possible. So dp of I is equal to false. I don't know if that's correct. No, didn't like this. Okay, that's gonna be annoying. Time exceeded. So we should have... is this one right? I don't know. And is more efficient than the pure recursive version you had earlier. Okay. This time complexity is roughly O of n squared. Okay. So these are huge numbers, and okay, I think what it's telling me is that I did do it correctly, but there's just more optimizations that I need to do. For jump in range, and I start at 1, okay? So I'm just going to keep going. And like eventually I should get to, because I'm going to do 1 1 1 1 1 1 1 1 1 1 1 1 1. I'm going to come here. I'm going to say it's not possible, so I should jump back to here, and then I do 2 and do ding ding, and that's not possible. 3 4 5 6 7 8 9. Oh, I see what's going on. But with this one, I should come here 10. So I come here, I should already see that this one is not valid. Then I see this one's not valid, but I have to try every single one of them. Okay. And then at that point, I can only then go up. That's not great. I see the problem. I just don't see the immediate solution. Would the tabulation method be able to solve this? Because I would be doing from bottom up. So it would be here and say, like, or actually, I would start here, I think. Say, can I reach? No. 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 But then I would still have to do all of those calls. So I would still need to do a for loop all the way up for every single one. So it would still be n squared. Or no, wouldn't it even not be n squared? Because it would be like the number n times like n. If n is the number of, like there's 1,000, there's 10,000 elements here. Okay, so n is equal to 1,000. And for this one, I need to go 1,000 tries. So I need to do a for loop for each of the elements. And in the worst case scenario, the element is 10,000. So I need to do that for loop from 0 to 10,000. So tabulation doesn't seem like it would also be correct or like efficient enough. So huh. Okay, let's see. What is the best way? All right, because I can't figure it out. Okay, let's see if this works. First off, we're just going to see if it works, and then if it does, then we investigate it. Okay. So it works. I don't know why. We'll have to figure this out. Let's see. What's even going on here? For I in range, so we're just doing this one time, yeah? If I is greater than max reach, 0, return false. Max reach is what? Something to do with canceling out those elements which we already know to be false? I don't know. Max reach and I plus nums of I. So my current location plus how far I can jump. And that's the max reach. Okay. If max reach is greater than or equal to the length of nums, so the last index, then we can return true. Because yeah, that makes sense. If we go over the max length, then we could just go one lower and we arrive to our destination. So, okay, that makes sense. Why that would be the condition here. The greedy method is linear time. Okay, so this is greedy, not dynamic programming. Oh, okay, well then that's why we got it wrong, is because we're trying to practice dynamic programming, but it was the problem was misclassified. Okay, let's just go back to this one and let's go to unique paths. Let's just keep going. All right, so there's a robot on an M by N grid. The robot is initially located at the top left corner, right there. The robot tries to move to the bottom right corner here. Okay, the robot can only move either down or right at any point in time. Given the integers M and N, okay, return the number of possible unique paths the robot can take to reach the bottom of the corner. Okay, so two things. Before I just move off of the last problem, I should at least think about how I could have known that it was greedy. Although right now I'm not trying to learn greedy. Like, I'm trying to learn dynamic programming. So the question I'm going to ask is, how could I have known to use a greedy algorithm instead of a dynamic programming approach? What should I look out for when deciding to use one algorithm instead of the other? And so, even though I'm not trying to learn greedy right now, I should keep in my head, well, when might I use, what are the flags that I should be thinking about when I'm greeted by one problem or the other? And so that way I can make an informed decision on which algorithm I actually choose. Okay, so when to suspect greedy versus dynamic programming. Greedy algorithm. The key trait, you only need to make local decisions that lead to a global solution. Okay. The problem asks, can you reach the end, maximize, minimize something without requiring the exact path? Yeah, we didn't need the exact path. Yeah, that makes sense. You can track a single running metric, like max length, instead of storing all subproblem results. The problem has monatomic property. Okay, what is monatomic property? Once you can reach further, you never need to go back. Okay, so this is something that I need to keep my eye out for. Monatomic property. Can you describe more about what monatomic property is? Okay. So, for dynamic programming, we say you need to consider overlapping subproblems and combine their results. Okay, combining results. Okay. The problem asks for counts, paths, or optimum values. Minimum jumps, number of ways, max profit. Multiple choices at each step matter. You need to remember results and avoid recomputation. Okay. Do I need the exact path? If no, greedy might work. Okay. So now I'm going to ask, like, what is this monatomic property? A function of sequence is monatomic if it always moves in one direction. Okay, we know about monotomically increasing and decreasing. That makes sense. If a problem has monatomic property, you can often use greedy strategy. Okay. How does that jump game actually embody a monatomic characteristic? I don't understand that yet. At each index, you can jump forward to nums of I steps. If you track the furthest index you can reach so far, that number is monotomically increasing, okay? It either stays the same or increases as you move forward. It never decreases because you never lose reach once you've gained it. Yeah, that kind of makes sense. Like, but if I say my max reach is here and then the next one is 1,000,000, it's way over there. I think I see what it's saying. Like if it's less than that max length, I'm gonna have to think about it. Okay, anyways, I'm gonna have to think about that one a little bit more. Let's just go to this one and see if we can distract ourselves from that. All right, so unique paths. Given the two integers m and n, return the number of possible unique paths that the robot can take to reach the bottom. Okay, so this one I'm going to do same thing like def recurse. And now this is going to be a 2D array, so I want I and j. All right, what is going to be the base case? That's going to be when I hit the finish line, right? So if I is equal to m and j is equal to n, and I think that this is m minus 1, right? Yeah. Minus 1 and n minus 1. Then we return... What do we return? We return 1, right? Otherwise, we return 0. So if I is greater than or equal to m, or j is greater than or equal to n, or we're out of bounds, I is less than 0, or j is less than 0, we return 0, because that's not a valid path. Okay. So now I should be able to, what are my valid movements? the robot tries to move to the bottom right corner, it can only move down or to the right. So I'm going to try down is equal to recurse, and then m and n minus 1, okay? And right is going to be equal to recurse m minus 1 and n, like that. And then I need to say that, hey, so my current location is now equal to the minimum of these. So like result is going to be equal to the minimum of down and right, but then I have to add 1. Oh, wait, no, I'm trying to find, wait, hold on, what am I even looking for? Given, return the number of possible unique paths. Okay, so the unique paths should be just adding these two. Like this. I'm just going to add this, and then I can return that back up and say, hey, I found how many unique paths for me. So I can just do like return this. And then I should be able to do return recurse on 0, 0. I'm going to keep going until I do all of these. No. So why is that wrong? So I need to figure out why I did this one wrong, because this is... Okay, let's figure out what's wrong with this. Current position. Ah. Okay. That one was just a little dumb one. That one doesn't count, okay? That doesn't count. So I and J. That was a dumb little mistake. I'm sorry. Okay, that one doesn't count. That doesn't count. Wait, hold on. All right, well, it didn't matter because I still got it wrong. Darn. Okay. Wait, we're moving to the right, so we're going to increase here, and we're going down, so we're going to decrease it. Well, okay, let's just copy and paste it back, and okay. What is the defined as M? So what is the... What did I do? Okay, this is correct. Out of bounds. This should be correct as well, right? And then down is recurse of I plus 1j. Okay, let me rethink this, I guess. So if I'm trying to go down, I want my row. Okay, so this one is row, this one is column. So I want down is going to be I plus 1, and then j is going to stay the same. Now, if I want to go to the right, it's going to be I is going to be the same, that's row, and now j plus 1. So I think that's correct. Okay, so we got this. Now, this obviously does not have the memoization, dynamic programming technique for saving your answers, so it's going to be a horrible time complexity. Let's submit this and see how many we get before we get time exceeded. But just trying to verify that, yeah, we got it correct. Like, theoretically correct. Have some walnuts. Okay. I need a 2D array, don't I? Darn. Okay. So, I want to build. So instead of 4, -1, I want to say 4. I'm going to create an array here. Each time in range m, right? M is the number of rows, okay? Now in here, I want to do -1 for blank in range n columns, okay? So m rows in columns. Okay, I think that's correct. So now I want to do here, I'm going to say if dp of I j does not equal -1, then I just want to return the saved value, okay? Otherwise, before I return, I want to save that value. Equals down plus right. Ha 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 ha! We got it. We got it. We got it. We got it. Okay, cool. So now What do... Oh my goodness. I just got a dynamic programming problem. That's so cool. Okay, okay, okay. So now let's see, how would I try to change this to be tabulation? I don't want to do that. I don't want I just want to take my win. Honestly, I just want to take my win. But let's try to push ourselves and okay, so changing our mindset. Now we are going into the tabulation mindset. Okay, what tabulation? I am now trying to go bottom up. So I'm going to be starting at the base case, right? So I'm going to be saying, here, let me come back here. How's that going to work? So I will now be trying to have an array. So we're no longer going to be doing recursive things anymore. I know tabulation, I'm going to be going for I in range M. Okay, for J in range N. Okay, I know that I need to do that. And then I need to fill out this 2D array. Okay. How do I want to fill it out? I need to start here at the finish, right? And I'm going to say there's going to be one way that I can do it here and one way that I can do it here. I think I need to auto put that in. I think I need to put that in before I do here. So I think I need to do like dp of m is row, okay? So row here, I'm going to say this one. So m minus 1, n is going to stay the same, that's column, is going to be equal to 1, right? Because there's one way to get to the finish here. Likewise, we are going to say dp of m, same of row, but column minus 1, n minus 1 is also going to be equal to 1, okay? And now I don't want to start here at the beginning. I actually want to start at the end. So I want to start at m minus 1. I don't think that this is quite correct, but then stop at 0 and increment by -1. I don't think that's correct yet, but I'm going to just write that down initially and then try to fix it later. Okay, so we do that, and then what I want to do is I want to say okay. What I'm thinking is if I'm here, I need to check, or if I'm like here, I need to be able to add this one and add this one, but I haven't calculated this one yet. Because if I'm going like this, I have not tried that one yet. Or I have not tried this one yet. The only two that I have filled out are this one and this one. From here. These all should be maybe 1. And then this should be 1. And then here I should add those. So then this would be 2. And then here I should add 2 plus 1. Okay, because that would be here. Then from here I should do this one plus this one. Okay. I think I kind of peeked behind the curtain. Okay. So, now how do I write that in code? So I want to do, if I'm at this location here, I'm not going to be looking there. So if I is equal to m minus 1, I don't want to be looking here. Is not equal, then I can look, okay? Right? Then result plus equals dp of I plus 1, and then likewise if j does not equal n minus 1, result plus equals dp of I, and we need to fix that, but of j plus 1 j. And then result is equal to 0, so result is equal to 0, and then I should be able to say dp of I and j is equal to result, okay? And then return dp of 0, 0. Are you guys convinced with it? I'm at like a 40% convinced rate. I think generally the idea is correct, but I'm not very convinced in my implementation of it. I think I made some kind of mistakes along the way. So we're going to start here, okay? M minus 1, n minus 1. It's this one. We're going to go to 0, 0, but this 0 is non-inclusive, so I think we actually need -1 there, and we're going to decrease by -1 each time. Then what I'm going to do is I'm going to say if I really hate this m. I hate this m. Okay. Row is equal to m, column is equal to n. There we go. So now what I'm going to do is row and column. Okay, so now if we are if we are here, if my current row column, okay, so if I is row minus 1 is not equal to row minus 1, the number of rows which is 0 indexed. It's always trying to keep in your head 0 indexed versus number of elements. Okay. So if we are not equal to the last row, this just means last row here. So if we're not equal to that, then we can add the number of ways like down here, okay? And if we are on the column here, if we're not at the last column, then we can add the previous one, okay? And then once we get to the stopping condition is at 0, and then we can return. Okay. It's scary. M minus 1. Okay, so this is going to be out of range if we are what? At what point would this be out of range? If m is 0 and n is 0? Okay, so obviously this has some kind of problem with the array we're declaring here and the values in here. So we're doing a 2D array, and we have the first element is going to be in range m. That's the number of rows. Yep, here. It should be correct. And then inside of that, we index here, which is n, the number of columns, okay? So m and n, they're non-zeros, so it should be the case that we are okay. So why are we not okay? M minus 1. So m is 3, n is 7. So 2 and 6. Or I guess 2 and... oh, is it... No, never mind. Range of n. So this is 0. Oh, wait, hold on a second. So if I'm here and I want to do here, right? What that should mean is I am at my last row, and then my last column, that's here. So that's m minus 1, n minus 1. But now I want the one right above it, so that is going to be row minus 2. And then this one is also going to be m minus 1. So m minus 1 here. And now I want n minus, here's n minus 1, here's n minus 2. So kind of like that. So I think that's what it wants. Let's see. Okay, we still got the wrong answer, but we didn't get out of bounds. So we're improving a little bit. Okay. We have the result and we plus equal it to there. So why would that be the case? We're getting 0. We're outputting 0. Well, am I just filling everything with this 0? Does not equal. Then we do this. Oh, why? Hold on. I don't know. I have no idea. I'm gonna try to take a little bit of a coffee break and see does my brain like think of anything? Well, I'm starting at the last one, and I'm going column by column. And when I was kind of describing it, I was going row by row. Wait, no, I am going. The row stays the same. And column, yeah. So all of this should be 1, right? Because result is going to be start here. Maybe this one also needs to be 1. So maybe I say dp of m minus 1 and n minus 1 is equal to 1. Because here, yeah, because I'm just overriding this value, right? And then in that case, I don't even think I would need those. I don't know. Because I'm coming here and I'm adding it. Is 0 plus 1? Is 0 plus 1? 0 plus 1, 0 plus 1, 0 plus 1, 0 plus 1. And I'm saving that in here. So all of these are going to be 1. Then I come here. It's 0 plus 1. Then I come here. It is 0 plus 1 plus 1. So it's 2, and I save that here. And then I do the same thing here. So I want to see print result. Zero. Why are we getting zeros? Print hit 1, print hit 2. Okay. Wait, if we're hitting, hit two, hit two, hit two. Yeah. And then we should be hitting both of them. Yes, okay, it is as I'm expecting, but okay. So that indicates that this result is this one right here is not accurate. Is that correct? So this should be, like at the very beginning, it should be ones. It should all be ones. So I should say, maybe I'm resetting it. So I think I should have just taken my win. I shouldn't have attempted the tabulation. Ah, that was a mistake on my part. Okay, fine. This is what happens when you're too ambitious. Well, I don't know. I have no idea. Because this should evaluate to 1 when I'm here. Row minus 1, column minus 1. So I start here. If I is equal to row minus 1 and a j is equal to column minus 1, then I just want to continue. Because I don't want to change. I don't want to change it. I just want to keep it as 1. Yes! 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 Okay! We got it! Oh my goodness! We got both the dynamic, or the recursion way, we got the memoization way, and we got the tabulation way. Oh my... Yes! Finally! Dynamic programming problem. Let's go. Oh my gosh. We got both. Oh my goodness. Can you believe that? We were able to pull off a dynamic programming problem. Just Out of our heads. Out of our heads. There it goes. There's a dynamic programming problem. Bam! Even better than that. Here's recursion, memoization, tabulation. All three. Just let's go. Let's go. Oh my goodness. Yes. Yes. This is correct. This is the way to go. Oh my goodness. Oh, I'm so happy. I am so happy. I never thought that I would be able to do a dynamic programming problem. I oh, oh my gosh. I can't even describe it. Okay. Well, thank you guys for watching this video. If you want to watch more leak coding videos in the future, subscribe. I'm going to be doing more leak coding videos, more engineering investigation videos, more project videos, etc. If you're interested, subscribe. I would love to have you around. My name is Timothy Lee Grant, and yeah, thank you for watching. Have a wonderful rest of the day. Goodbye.